Number 5, let S equal 1, 2, 3, 4, 5, 6. That's the sample space for tossing a single die. Let E be the event 4, 5, 6, and G is the event 1 and 2. Draw a Venn diagram showing that E and G are mutually exclusive events. So this is kind of a weird question here, but you're going to have event E, and there's a 4 and a 5 and a 6 floating around in there. And event G is a 1 and a 2. Okay, and so you notice that there aren't any elements in common. There's no overlap. So drawing these circles like this, there's no overlap. Those things are mutually exclusive. Make sure you draw a box that normally represents the universe, but we're calling it the sample space. So I'll put an S there for sample space. And the only thing left in the sample space that's not drawn is the number 3. So let's put a 3 in there. So this is a Venn diagram for that particular situation. Basic probability has a formula, and it looks like this. It's a lot easier than it looks, though, because it's probability, so it is what it always is, part over total. You've seen probability before, and you'll see it again. The problems can get really difficult later on in the next chapter. They're going to get pretty tough, but probability is always going to be part over total. Probability of an event is a number between 0 and 1. And you already knew that. Number 6. The probability of an event, suppose a single fair die is rolled, use a sample space S equal 1, 2, 3, 4, 5, 6, and give the probability of each event. So part A says the die shows an even number. Let's look at this. The event for an even number is 2, 4, and 6. So I'm going to write a lot more than you would probably want to. The probability of that event, according to the formula, is the number of items in that event over the number of items in the sample space. But that's just part over total, okay? You would need to ask yourself, how many elements are there in event E? Well, there are 3 even numbers. And how many are there total in the sample space? There are 6. So I know you're going to want to skip steps here, and that's fine. If you don't need to write all that down, don't write all that down. But do reduce your fraction. You get 1/2. Or decimal is 0.5. That's fine. So the next one, we've got the probability of F. Whoops. Let's look at what F is first of all. It says the die shows a number less than 10. Well, isn't that everything? 1, 2, 3, 4, 5, 6. So probability of F is equal to the number of elements in F over the number in the sample space. Well, there are 6 elements in F, and there are 6 in the sample space, and that reduces to 1. That's what's called a certain event, okay? A certain event, right, has a probability of 1. We know it's going to happen. What's the probability that you get a number less than 10? 1. It's a certain event. G says the die shows an 8. Well, there is no 8, so that's the empty set. G is an empty set. If I'm finding the probability of G, I'm finding the probability of an empty set. The number of items in G over the number of items in the sample space, that's 0 over 6, which is 0. That's impossible. So it's an impossible event. Okay, the next slide, I'm not going to read all this to you, but it is kind of important. Some of you have an advantage over others, some of you that have played cards before. If you like to play card games, if you've played poker, if you've played euchre, whatever the card games are, if you know about a deck of cards, you've got an advantage because a lot of probability problems revolve around your knowledge of playing cards. For instance, do you know how many cards are in a deck? 52, correct. How many suits? There are 4 suits. They are hearts, diamonds, clubs, and spades, right? How many cards are in each suit? 13 in each suit, correct. How many 7s are there? 4 7s. How many red 9s are there? 2. How many face cards are there? That's 12. That's a tough one because people always think that ace is a face card, but a face card literally has a face on it. And so the king and the queen and the jack have faces on them. So there's king, queen, jack of each of the four suits. That's 12 face cards. So there are a lot of different questions that you need to know about a deck of cards before you can answer some of these probability questions. Number 7, if a single playing card is drawn at random from a standard 52 card deck, find the probability of each event. Drawing an ace. So remember, the formula says we want the number in that event over the number in the sample space. Okay? So basically, we need to ask ourselves, how many aces are there? What? 4. Very good. And how many items are in the sample space? 52 cards in a deck. 4 over 52 reduces to 1/13. So you're probably going to need to reduce your fractions. How about a face card? Probability of a face card. So again, it's the number of face cards over the number in the sample space or the number in the total. How many face cards are there? 12 out of 52 cards in a deck. 12 over 52, you can reduce that. 3 over 13. Drawing a spade. I'll usually draw a picture of a spade instead of writing the word, but whatever. Probability of a spade. Do you know how many spades there are in a deck? 13, that's correct. 13 out of 52 total cards. That reduces to 1/4. And that should make sense to you because spades is 1/4 of the entire deck. Okay, each suit is 1/4 of the deck. Next one, drawing a spade or a heart. Well, how many? 26 spade or hearts. 26 spades or hearts. That sounds right. That's half the deck right there, right? 26 over 52 is 1/2.